Hello and welcome everyone. Today in this lecture I'd like to talk about myocardial protection and cardioplegia during an open heart surgery. Okay, so why do we need to protect the heart during an open heart surgery? When a patient is in a bypass machine during a heart surgery, we stop the heart to give the surgeon a quiet and motionless field to work on. Okay, you could imagine it's pretty tough and challenging actually, and sort of impossible for the surgeon to work on a heart when the heart is pumping. So the heart should stop to give that chance for the surgeon to work. And here is the problem. If the heart is stopped, okay, therefore no oxygen is being delivered to the heart itself, because the heart is, we know it's an organ that pumps blood to the body, but also the heart as a muscle, it needs oxygen, okay? So here is the point, here is the main key, how we could protect the heart muscle, okay, during this operation when we stop the heart from beating. Because if the heart stopped, okay, there's no oxygen. Therefore, even after surgery, when we restart the heart, and we're going to talk about this in details in moments, maybe weak heart functions gonna show up after the surgery. Even sometimes dangerous arrhythmias, means like if we do a ECG, EKG electrocardiograph, or ECG, doesn't matter, on the heart of the patient, you could see there is obviously arrhythmias, means abnormals in the electrical activity of the heart. And even sometimes it could lead to heart failure. Okay, so we have to stop the heart from beating, at the same time protecting the heart. Okay, and this is one of the biggest rules actually for perfusionists, for cardiovascular perfusionists. Okay. So here we have to define the term cardioplegia. Okay, what is a cardioplegia? It's actually a solution, a special solution that stops the heart from beating but in controlled way. Okay? Means like the heart would be in relaxed state. Okay? We stop it, but we control it as well. Okay? So we could start it and restart it again. So what this solution does actually, it cools the heart to slow down metabolism, okay? Because if the rate of metabolism was low, means less oxygen is needed, okay? Also provides nutrients and other chemicals to reduce injury of the heart while it's stopped. So think about it like if the heart is stopped, but the metabolism rate is low, therefore there's less consumption of oxygen and less consumption of nutrients, okay? Therefore, less damage, significantly less damage to the heart muscle could happen after the surgery. Now, the principle actually behind cardioplegia is the heart stops because cardioplegia contains a high concentration of potassium, okay? And what actually does potassium do? Potassium actually changes the electrical balance of the heart cells and freezes the heart in diastolic phase. Diastolic phase means when the heart is relaxed and filling with blood, okay? That actually protects the muscle by stopping it from using energy. Just like if someone underwater, a person, and this person could sink, right? But if I told you he's not breathing, like he's not letting water to go into his lungs, just an example or something to fully understand. Well, actually there is types of cardioplegia solutions. There's two main types. First of all, we have solution that actually is made of either blood or it's crystalloid. Okay, So this is the first main difference about the cardioplegia, the material, or whether it was blood or something else, crystalloids. Second difference, which is temperature. Does the temperature of this cardioplegia is warm or cold? And the way I could give it, in a continuous way, or maybe as doses, that of course all make the cardioplegia solution differs from other types. Of course, all are usable, but depends on the type of operation and the status of the patient. The first, let's impact one by one those types. Blood cardioplegia, which believed to be the best actually for the heart, it actually uses the patient's own blood mixed with potassium and other materials. Okay, it has oxygen, it has nutrients. Okay, it could be used as cold or warm. The second type of cardioplegia is crystalloid cardioplegia, made mostly of water, electrolytes, and potassium. It's easier to produce, to prepare, but it doesn't carry oxygen because it's not blood. Okay, and they use it in a cold temperature. Well, think about it. Why do we cool the heart? Okay, think about why we put food. Okay, why we freezing food, for example, because it stops the food from spoiling. Okay, pretty much the same idea. We cold temperature slow down the metabolism rate of the heart. Metabolism rate of the heart would be significantly lower when the temperature is lower. Okay, this gives more time to safely keep the heart stopped. As mentioned, there is two types. There is either cold, okay, cardioplegia, about 4 Celsius, the temperature of it, and there is warm cardioplegia, about 37 Celsius, okay? Now, how we deliver actually cardioplegia into the heart at the beginning of the surgery. There's two main ways actually. The normal direction, and we deliver this cardioplegia solution through the aortic root, okay, the big artery coming out of the heart. And actually, cardioplegia in this situation flows into the coronary arteries just like normal blood flow. Okay, like how the blood flow goes through the heart, exactly the same way. This is we call the normal direction method. The second way, which is the backward direction, okay, delivered through the coronary sinus, a vein that drains the heart, okay, and cardioplegia flows backward into the coronary venous to reach the heart muscle, okay. And now we could ask a question, when we use each method actually? Well, that of course depends. If the coronary arteries actually are blocked, or we have leaky aortic valve, okay, this way we can't use the normal direction way. We're going to use in this scenario the reverse or backward direction. Now, how often is cardioplegia given? Well, sometimes depends on the type of the operation and the situation of the patient. We could give it every 50-30 minutes during the surgery, like small dose. We could give it continuously. A steady, small amount is delivered through the whole time of the operation, or a single shot, which is actually big dose, is given. Okay, that would be enough for the entire time of the surgery. Now, what is the equipment actually needed for this procedure, injecting cardioplegia into the heart? We need, of course, a pump called the cardioplegia delivery pump. Controls the pressure and flow of the cardioplegia. Depends on the type that we mentioned just before. We need a heat exchanger to adjust the temperature of the cardioplegia. We need something called cannula, which actually it's tubes, different types based on the normal direction way or the backward direction. We're going to talk about cannulas in more details probably in the separate videos, how we connect them to the heart or something. And we need, of course, pressure monitor. Okay, very important, because sometimes if the pressure of the cardioplegia solution is high, that could literally damage the coronary's veins. Okay, if the pressure is very high, think about like you're pumping water with very, very high pressure into tubes. That could actually make the tubes blow up. Okay, so it's very important to control the pressure of the cardioplegia. Okay, so if the cardioplegia, or in general, if the protection of the heart muscle failed during the surgery, what we could expect. Okay, the heart may be weak when we try to restart it again after surgery. The heart may be not pump well, like low cardiac output. Arrhythmias with different types could appear, and as we mentioned, that could also be related to heart failure. Okay, so we need to go through the operation and making sure that after we restart the heart, the heart would be as strong as it was. Okay, less damage possible. I mean, like literally very, very small damage. Okay, we can't even notice when we make like ECG or something. There is actually other protection techniques other than the cardioplegia solution. First of all, there's something called ischemic preconditioning, which means we train the heart to be ready for small amount of oxygen. Means train the heart to tolerate the longer stop during surgery. Okay, because it's like a muscle, need to be trained. You can think about it like that. Something else, actually, we could give some drugs that reduce the damage from lack of oxygen. Other way, which is temperature management, as we could say, but we should carefully warming and cooling to avoid injuries. Okay, so like there's no temperature shock, as you could call it. Like sometimes when we have a glass, it was very cold and suddenly you warm it up, it will break. The same thing, you have to be like warming and carefully, like raising temperature or cooling temperature, step by step. Okay, and actually a good glucose control, because high blood sugar during surgery could worsen heart injuries. Okay, so avoid high blood sugar during an open heart surgery. So that was the lecture of this. Actually, the sources of this lecture was from a book called Cardiovascular Bypass from Cambridge University, 2nd edition, just to clarify where those information are from. And this is mainly the 7th chapter in the book. I hope in the future, of course, near future, I'm going to make more videos talking about more topics about profusion that every perfusionist, actually, or cardiologist should care about. Thank you so much, and goodbye.